So I'm going to start off with looking at some documentation on our portal. It's going to come as a shock to you guys, because I know it's none of you, but it turns out that some significant fraction of the questions we get as JIRA issues are because people didn't read something that was here. So I know none of you guys are in that camp. In your defense, if you haven't read the whole portal, there is a lot on there as far as documentation goes. And I do recommend using the search. So we have a great keyword index now into the portal. If you know one or two words in search, you'll probably get the page you're looking for in the top couple. So. Back to where I was. Actually, let's just navigate there. So user guide and profiling. There are a variety of ways to profile your code. I'm not going to go over everything today. I will name a couple of my top personal favorites. gprof, if you haven't used that before, it's just in Linux. And I also like MPIP. Those two together, especially when I'm looking at the serial portion of a code, gprof gives me the sampling of how things are going in the code itself, and then MPIP gives me the sampling of how time is spent in the MPI calls. So those are a good combo. gprof also does have an option that will output a gprof profile for each rank. So if you run it at small rank sizes, that's pretty doable. Our focus today, though, will be on things Cray and Blue Waters, because this is the Blue Waters Symposium. So I'll be a little bit of an advert for Cray. A lot of the things that are on this portal that I'll show you today are new to us as of the last Advanced User Workshop. So Cray is always changing things and adding features, and some of this stuff showed up in the fall, and we caught it in the spring when Louise DeRose and Heidi came by and showed us the new way of doing things. One of them in particular is just right at the bottom of this profiling page. We thought this was an important enough concept to just stick it on the profiling page itself. If you do a man on MPI, one of the new environment variables in the Cray setup is impitch memory report. And if you set that guy to 1, 2, or 3, you will get various levels of reporting about the memory use by your program. And this is, I would say it's in the top 10 questions that we have been getting asked through the life of the system, because it's not easy to go out to the node. You can't SSH onto it like a traditional Linux cluster and look with top. So Cray has provided this. It works really well with the caveat that your code does need to complete for you to get your memory report. So this isn't a way to quite figure out why you got killed by OOM killer and the kernel, but if your code does run and finishes with a reasonable exit, then you will get these memory reports. It might be a handy way to sort of titrate your way up to using as much memory as you care to use on a node. So I'll leave that with you. Question from the admin.
What's the memory report look like? So
It's a text file.
So the question was, what does the report look like?
Yeah, so the report's a simple text file, and it shows just what it says, min, max, watermarks. So, and actually it's gonna go to standard error. So however you're handling that in your PBS batch directives is where that's gonna end up. Unless you do number 2, and then you can direct it to files if you're choosing. So. Okay. All right, the second thing I wanted to say a few words about before we got to the Cray tool that's really my interest is AppRun. AppRun is not a performance tool, unless you ask Greg, then he would probably say that Well, it does have a lot to do with performance. So if you're coming from a Linux cluster where you have things like OpenMPI or MVAPIC, if your admin team on that cluster has done a crackerjack job, it's possible that the defaults for MPI run or MPI exec give you pretty good placement as far as ranks onto cores and how the ranks spread onto nodes. Now that's not guaranteed, but I have seen OpenMPI installations where admins really did their homework, and this is done well. On the Cray, you need to put your hands on the controls with app run. It is the Swiss Army knife that we have for placing your ranks onto cores the way that you want. So when you're running big jobs at scale, NUMA placement typically matters, especially if you're doing threads. If you're just doing all pure MPI, maybe this isn't quite as big a deal for you, but definitely if you're doing mixed hybrid OpenMP and MPI, you're going to end up caring about these flags and options. If you go ahead and look at our sample batch scripts, we have some recommendations for how to set these for what we think are good performance defaults. And if you have a feeling like your code should be running faster than you believe it's running on Blue Waters, this is the first place to start. And if you want help, ask us for it, because we'd be glad to do some test runs with your code and try to figure it out for you if you need that level of help. Now on to the meat of what we were going to look at. So the one particular tool, Cray Performance Measurement Analysis Tools, has had some updates recently. So last summer, we had a new update from Cray called Perf Tools Lite. Initially, Perf Tools was a very hands-on tool. If you read the man page, you got a nice long recipe. I had to make my my terminal about 4 times longer on a big monitor and read that man page carefully. And it took me a couple tries to where I could get a good performance run. Perf Tools Lite came along, and it's a swap out Darshan, load Perf Tools Lite, and rebuild your code, and then run your code, and it generates some resultant profile output that you can analyze. So they took a lot of the guesswork or manual steps out of it, and then in the fall, they added more modules to this. So Perf Tools Lite is the same as it was. It's a basic time sampling. It'll do what gprof can do with a lot of Cray additions to that. You get a nice GUI, and we'll look at that in a moment. Perf Tools Lite GPU will do this for GPU kernels, which is pretty spiffy. These guys will talk more about GPU profiling, but this is sort of your entry level if you want to just get a real basic start with GPU profiling. Perf Tools Lite GPU. And then Perf Tools Lite Event does some function tracing, and Perf Tools Lite Loops does loop analysis and can be used with the Cray Reveal tool. I won't get into the Reveal tool. It's not really a performance tool. It's more of a partly automated OpenMP programmer. So Cray, if you haven't heard of Cray's Reveal, you can think of it as having something that'll generate your OpenMP loop markups for you. And what Cray has done here is they've linked Perf Tools and Reveal together so that Perf Tools can figure out where time is spent and which loops are spending that time, and then Reveal can come along and you can mark those loops up and say, I would like to see what the OpenMP directive for this loop looks like. Or Reveal, on the other side, might look at that, say that you've got a data dependence, and you'll have to work on that. So here's the setup. I chose the stream benchmark, and so that the The outputs we'll have are just from running a stream on a single node of Blue Waters. We run stream on everything as performance people. Whenever a new chipset or a new board comes out, Greg's first question is, what's the stream number for that hardware? So on machines going all the way back to the earliest NCSA days that I was there, we've run this. I've run it lately on Raspberry Pis. I hacked up a version and ran it on an Arduino. Arduinos are not big compute powerhouses. If you're going to do a top 500 on Arduinos, you're going to need a whole lot of those, a lot of wire. Oh, and the new Raspberry Pi 3 is about where computers were in the late 90s. So not terrible for $35. So here's the setup for running the Cray Perf tools. The first thing to do for any of the Perf tools, performance tools, or even some of your own tools that you may bring yourself and build, is typically to unload Darshan. Darshan is a performance tool for I/O, and it's intercepting MPI init and finalize and wrapping your code, and so it gets in the way of other performance tools. So in general, it's best to use one performance tool at a time. We occasionally will use two, but when we're doing that, we're using just some expert knowledge there. So then I load Perf Tools Base. That's the module with all the things that you need to visualize. And then for this first experiment, I did Perf Tools Lite. Rebuilt, rerun, and in the output directory, then I had a stream with a unique number and a .ap2. That's an Apprentice2 file. And when I run that app2 command on it from a login node, then I get this. So that's the basic screen, and then you can do a pie chart. You can get a feel for how the code is spending time. This one shows some loops. Stream's just doing basic matrix operations and giving you your memory bandwidth on the machine in a couple of different views. This is the text report that you would also have next to that AP2 file, but it's then been pulled into the GUI. So there is a text report like this in the same directory. You could look at that. You could look at it through the GUI. This one's kind of interesting. There are a few performance counters by default. So if you'd like to see some things about cache use or TLB data misses, floating point ops, there they are. The next one we're going to look at is just a quick look at Perf Tools Lite events. The one that I thought was sort of neat in this experiment was that this one has I/O rates and where that's coming from in your code. So even though we've unloaded Darshan, you can get some of that out of Perf Tools. So I wasn't aware of this. This is new to me. I haven't used it on one of your codes yet, but I expect I probably will soon. So it's on my to-do list to look at more. And then loops. This is the view of Perf Tools Lite loops, and it's really focusing just on loops in the code and trying to keep other things out of your view so that you can put your attention there. These Perf Tools Lite, even though they have Lite in the name, they do run Perf Tools in a fairly full-featured way. So things that you see from the Perf Tools standard man page still apply here. So in this next example, I set the pat-rt perf counter environment variable to select a couple performance counters that I wanted to see in this next run. And when I ran that way, then I had the two performance counters that I specified, data cache misses and TLB data misses, along with loops that were contributing to those counts. So perf tools can, if you mix and match and do a couple runs with the same piece of code, you can go from sampling, okay, where's my time spent, to you can probe into deeper questions with like the I/O, or am I spending time using the hardware the way I think I should be with looking at the performance counters. Some of you who run really big probably have an expectation of what your peak flops ought to be. This would be an easy check to see if you're in the ballpark. If for some reason you were not, my first guess would be going back to app run and seeing if things got placed on the cores the way you thought. An easy way to get that flop count to be off by a factor of 2 is to run with the 32 integer cores on a code that's floating point intensive and well-tuned. Another note for threaded code, the perf tools will usually give you just one core or thread's worth of counters. They don't, from my testing, they don't seem to aggregate all the threads back together. So you get a thread's worth of results. Artifacts from the wiki page, you can be the first person to like this presentation. And that's all I had. So I tried to move us up a little bit in time.
All right, thanks, Galen. We weren't really behind on time, so that's all right. But now we're ahead of time. So we have time for questions. We got one over here. All right. Go ahead, Carl.
Sorry if you mentioned this and I just missed it, but what's the approximate runtime impact of using this tool?
Less than 1% or 2. It's, well, let me back off. Depends on which one. The sampling is down in the noise, so like 1%. Because it is just sampling. It's just jumping in at a time slice interval and looking to see where the code happens to be at that interval. The ones that do tracing can be a little bit more perturbed, but the sampling and the loop analysis, essentially free. Yeah. I've not done enough with the GPU version of Perf Tools Lite to say. So that could have an impact. I didn't look at that. Greg was the last one to use that. So he was using it to verify that something was running the way he thought it was.